Welcome back, guys. As you know, we're in Chapter 5, and in Chapter 5 we're dealing all with graphing and writing the equations of lines. And today is a very special day because today we are going to leave slope-intercept form behind, and we're going to learn about a new form. Remember I told you that the equations of lines, you can think of them like transformers. They have robot form and they have vehicle form. And so there's lots of different ways that we can write an equation of a line, and it looks different, but it still describes the line. So we've learned slope-intercept form. Now we're going to talk about a new type of form called standard form. On standard form, the formal definition, like the real definition, is this. It's ax plus by equals c, where a, b, and c are real numbers. So like this would be a number, this would be a number, and this would be a number. They are real numbers, and A and B are not both zeros. Okay, so one of them can be zero, but the other one can't. And then they can't both be zeros. But the important thing that I want you to pay attention to is that standard form is when x, if my pen will cooperate, and y are what? What do you think? Taking a look at standard form, what is so special about x and y in this form? They are on the same side. On the same side. X and y on the same side. X and y on the same side. It's kind of like a little rhyme. And what am I talking about when I'm talking about on the same side? Well, I mean on the same side of the equal sign. Here's our equal sign. Notice that x and y are over here on the left, which is different than slope-intercept form. Slope-intercept form, remember, was y equals mx plus b. And in slope-intercept form, you've got the y, if this is our little dividing line, y is over here on the right, and x is over here on the left. So before they were separate. Now we've put them together on the same side. And if x and y are on the same side, then it's considered standard form. Okay? So that's what standard form is. Now, what do we do with that? Standard form is used most often to help us find the intercepts. Now, remember, the intercept is wherever the line crosses an axis. For standard form, we're going to be looking at both intercepts, okay? So let's take a look at how we do this. To find the x-intercept, remember that's where the line crosses the x-axis, we are going to plug in 0 for y. Plug in 0 for y. And then if you are looking for the y-intercept, you are going to plug in 0 for x. Why does that work? Well, take a look at this graph. You can see that the line crosses the x-axis here, and it crosses the y-axis here. And for both of those coordinate points, there is a 0. On the x-intercept, the 0 is in the y place, and there's a number in the x place. That tells us that at this number on the x-axis, the line will touch. Also, for the y-intercept, there's a 0 in the x place, and in the y place, there's a number. That number tells me that this line will cross the y-axis right at this number. So to figure out what those numbers are, we're going to have to plug in 0 for the opposite. So to find out what the x number is, plug in 0 for y. The intercept will be an ordered pair, okay, because all points are represented by an ordered pair. It'll be an ordered pair with the x-intercept being in the x place and 0 in the y place. Okay, that's how you'll write it. For the y-intercept, you plug in 0 for x, and it will be an ordered pair where the 0 is in the x place because you plugged it in, and there will be a y value. The y-intercept will be in the y place. So 0 in the x and a number for y, whereas the x-intercept had a 0 for the y and a number for the x. It gets kind of crazy, but just remember, if there's a number in the x place, that's where it hits the x-axis. Number in the y place, That's where it hits the y-axis. All right? So let's take a look at some examples of how we're going to be finding these. All right, so number 13. First thing I want you to do is write the equation again, because we're going to be plugging in twice here. So go ahead and write it 2 times. All right? Whatever they give you, just write it again. Now, what happens if we plug in 0 here? If we plug in 0 for this x, it's going to disappear. And the only thing we will have left is the 4y. So what we can do is just cover that over and solve what we have left. If you cover the x-intercept, you are finding the y. So if we divide by 4 here, we can see that this will cancel, and y equals 16 divided by 4, which is 4. That's the y-intercept. So under y-intercept, we would put 0 for x, 4 for y. That's where it crosses. Now for this equation, remember we did it a second time because we have to find both of them. If we plug in 0 for y, well, if this is a 0 and we multiply by 4, it's just going to be 0. This whole thing will disappear. So you can cover it over and solve for x. X is already all alone. X equals 16. So that tells me that my x-intercept will have a 0 in the y's place, and the x place is going to be 16. So that is the point where this line will cross the x-axis. Let's take a look at a few more examples. Here we have x plus 5y equals negative 5. I'm going to write it again, exactly the same way. To find the x-intercept, I'm going to plug in 0 for y. If I plug in 0 here, this whole term becomes 0, because anything multiplied by 0 is 0. Then I just have x equals negative 5, which means in my coordinate point, x will be negative 5, and y will be 0, because the intercepts are always 0 for the other place. Now looking for the y-intercept, I would plug in a 0 for x over here, and it would basically disappear. And I would be left with 5y equals negative 5. Solve for y, get it all alone, and y equals, negative 5 divided by positive 5. That's a negative 1. So in my coordinate point, I plugged in a 0 for x, and my y is negative 1. So that's my y-intercept. Why don't you pause the video, tackle number 15 and 16, come on back when you think you've got it. All right, for number 15, I put it in there, I wrote it twice. Now I want to find my x-intercept, so I'm going to plug in 0 for y, which will knock out this whole term, and solve for x. X equals negative 12. So in my coordinate point, x is negative 12, y is 0. Now for my y-intercept, I'm going to plug in 0 for x. That'll knock out this whole term, and I'm left with 4y equals negative 12. Solve for y, and y equals negative 3. Is that what you got? 0 for the x, negative 3 for the y? I hope so. How about for number 16? You should have written it twice. For the x-intercept, plug in 0 for y, which will knock out this whole term. And then you just have x equals 8. So in your coordinate point, x is 8 and y is 0. For the y-intercept, plug in 0 for x. That'll knock out this whole term. And then you will solve for y. So y equals, positive 8 divided by negative 4, that gives me negative 2. So 0 for x gives me negative 2 for y. And that's my y-intercept. One last one. Pause the video, tackle it on your own, come on back to check your answer. How'd you do? Did you catch that negative symbol? It doesn't disappear with the other term because remember, it stays attached to whatever comes after it. So you would have to divide by negative 1 to get the y completely by itself. And of course, a negative divided by a negative is a positive, and 3 divided by 1 is 3. So our y-intercept then is 3. These last 5 I want you to tackle on your own before you come to class tomorrow. But I bet you can do just fine. If you have any questions, be sure to put a star by it, and I'll be happy to help you when you come in tomorrow. Thanks so much for watching. Have a great night.